All right, now let's have a conversation about density. Density is an intensive property that relates the uh, mass of a given substance to its volume. All right, density is the mass over the volume of a given substance. So the SI units for this are kilogram per meter cubed, but you'll see us use a lot in class this form of expressing density, grams per milliliters, and that's usually for solid materials or liquids, and grams per liter when we're expressing the density for gases. All right. The density of water. Do you remember what the density of water is?
Should I know that?
Well, we talked about it last time. We didn't. We only lightly referred to it as density, but we said that 1 milliliter of water, right, which is equal to 1 centimeter cubed of water, had a mass of 1 gram. So I'll draw it. Here's my cubic centimeter or 1 milliliter of water. All right, it has mass of 1 gram. Therefore, the density of water is, we take the mass of this material divided by its volume. All right, I can express it in milliliters or cubic centimeters, but the resulting density is going to be 1 gram per milliliter or 1 gram per cubic centimeter. Does that make sense?
Yeah, I think I got that.
So by taking the mass and dividing it by the volume of a given system or a material, you will get the density. All right. So sometimes when we express measurements, it's not really measurements, but it's actually exact quantified defined values. So for example, a foot is defined as 12 inches, or you could say an inch is defined as 1/12 of a foot. All right. So in that scenario, those are exact values. So when I say there's 12 inches in a foot, I'm not saying that a foot contains, when I say 12 inches, I'm not saying it's either 11 or 13. Because this is an exact number, um, there's exactly 12 inches in a foot. So sometimes numbers that are expressed like this are definitions and they're exact numbers. All right. Um, all of our other measurements are not exact. And because of that, there is, again, an uncertainty, and we need to know how to express that uncertainty. So if I look at this graduated cylinder, graduated means that there's marks on it like this. When you graduate, there's a mark, a way to define where you're at, right? So if I look at this graduated cylinder and I want to know how much water there is in it, how can I express that in a written fashion to show somebody how much uncertainty I have in the measurement? Well, if this is 10 right here, let's see, there's 15. What does that make this mark right here?
That one's 11.
Very good. 11, 12, 13, 14, and 15, right? So this one above the 20 must be what?
21.
Very good. And we make a measurement of something like water at the bottom of this little, what we call a meniscus. At the bottom of this meniscus here, we identify where we're at and we draw a line straight across there and try to identify whether this is where it's at between the 20 and the 21 mark. Okay? If this is 21, this is 20, what would you say this one is?
20.5.
Okay, 20.5. I might say 20.6 because it's a little bit more, but that's where the ability to express uncertainty is. If I say, whoops, if I say 20.6, 20.6, and the units are milliliters,
Okay.
20.6 milliliters. By writing this down, I'm telling you that the sixth the 6 there is the uncertain value. So it might be 20.7 or it might be as low as 20.5. All right, but this is how much I have determined based on a known value, and then the last value is always my estimate. All right, and we say that there are 3 significant figures here. These 2 are significant figures because they were known. We could see them, and this one is significant because it's my estimate. I always get one estimate. All right. Okay. So when we're collecting many measurements and we're trying to determine the effectiveness of our measurements in terms of telling us a story or letting us know the actual value, we have terms that we use to express the quality of the data, which are uncertainty, precision, or accuracy. Precision and accuracy. If the result is high precision, that means that my values are all gathered in a single place. This is high precision. All the values are close to a single value. This is high precision. This is high precision golfing. All right. This is also high precision golfing. Accuracy refers to the average value being close to the actual value. So if I say I'm a great golfer because when I go golfing, on average, I always hit it right in the hole, right? Would that make me a good golfer?
Well, I guess so, if you always hit it right in the hole.
I didn't say I always hit it right in the hole. What did I say?
Oh, you said on average you always hit it right in the hole?
That's right, on average. So what does that mean?
I don't know.
Well, if I take the average of these different shots right here, right? So these are different golf balls where I always hit it. I never hit it actually in the hole, but the average of this is right in the middle there. I could say I'm a very accurate golfer. But that wouldn't make me an effective or a good golfer, would it?
No.
So I need to more than just be accurate. I would like to be precise as well. Precision is good here, for example, or here, for example, but without that accuracy being in the right place, then it's not good enough. So look at these 3 different dispensers. If I'm trying to deliver some cough medicine very accurately and very precise for patients, right? Which one of these dispensers would be the best dispenser? Well, the way we can tell accuracy is by using the average. Have you heard of an average?
Yeah, I know how to take the average.
How would I take the average of these numbers here?
You would just add them up, and then you would divide by how many you took, which is 5.
That's right. There's 5 values here. 1, 2, 3, 4, 5. So I add them all up and I divide by 5, and that gives me the average. And I've written the averages down here for these different dispensers. Have you ever heard of the standard deviation?
No, I don't know what that is.
Standard deviation is kind of like, it's a statistical tool that essentially expresses the average distance between the actual value and all of your different measurements. Okay? In this class, we won't be doing the standard deviation by hand, but we can look and see, using the standard deviation, we can look and see whether or not we can measure the precision of a test or a number of measurements. So of these, we're supposed to be delivering 296 milliliters. Which ones are accurate?
Dispenser 2 and 3 are accurate.
That's right. 2 and 3 are delivering the 296. Which of these are dispenser 1, dispenser 2, or dispenser 3? Put them in order in terms of precision. Which is the most precise?
Dispenser 3.
That's right, because the standard deviation is low. Another way of thinking of this, you can think of this value as 296 plus or minus 0.089. All right. Here, this one, would this be, how is this standard deviation? How's this precision?
That's poor precision. High accuracy, but poor precision.
Very good. So the Spencer one is precise but not accurate. Spencer 2 is more accurate but less precise. And Spencer 3 is both accurate and precise. Very good.